Okay, September 30th, Tuesday, and this is the second video. This is the first video where we're gonna power the unit on. We're gonna get some output, and we're going to transition. In the previous two videos, setup 1 and 2, we've shown the unit, and I want to show right now all connections. We're gonna bring in 240 volts, three-phase source on L1, L2, and L3. And that's what we already have here. These are the cables, cables right here, 1, 2, and 3. We also are picking up our output on the P and NP right here. And the signals that we'll be looking at is the voltage feedback out of TV2 positions 2 and 3. Right here, that's what we sent to a regulator, and the 50 millivolt shunt across, or the 50 millivolt across or shunt, that's also what we sent to a regulator. We have our DC output coming out of the P and NP signal on DC, and we have the AC input across L1 and L3. Okay. And the very first thing that we're going to do is we're going to apply 120 volts AC. This has nothing to do with the 240 here. I mean, they might come from the same source, but they don't have to be in phase. This is just simple 120. Shows TV1 position 16 and 19. So let's go ahead and turn that on. Okay. And there's a few little things that will happen. We'll have LEDs on here. We have the 12 volts LED telling us that we have power. The unit has a phaseless because we haven't applied the 3-phase 240 source. This LED, it's a polarity transition that will only turn on, will more likely blink when we command the transition, and the unit it's inhibited. The unit it's off right now mainly because there is a phase loss condition. That means that if there's a phase loss condition, the board will always inhibit. Even if we clear this, right now we have the board commanded to inhibit, so it will not turn on until we enable that, and we'll see that in just a minute. The signals that we're going to be looking at here is the output. We have a negative DC output, and then we transition to a positive value, and vice versa, and we'll show that here. And we're going to have here basically a delay angle. We're going to show the delay angle at which the board it's going to be firing, depending on the command. For this first part of the video, we are going to show the operation and voltage regulation. What we're going to do is the current limit potentiometer, we're going to set it to 100%. And this, by the way, we're not using positions 11 or 12, we're doing all on board here. And that's the current setup of the board. The current limit potentiometer, we're going to yank it all the way, pull it all the way to 100%, and we're going to control the voltage limit starting from 0. The current trip, on purpose, we can leave it at 100% so that the current for this particular video, it's not part of the picture. The current trip will come later on to limit the maximum output current. So now that we turn that on, now we must apply. There won't be anything that we can do until we apply our 3-phase source. Okay, now we're gonna have to be careful here because we have 240 volts, but now we have cleared that phase loss LED. The unit is basically ready to go, and we don't have an output yet. So let me go ahead and put it out of here. Okay. And I don't have an output, however, my AC input meter shows 238, 240 volts AC. So now we're going to go ahead and enable by opening positions 4 and 5, and that's where Tony has a switch. And now that we've turned on, we start to see a minimum output according to our meter, we only have less than a volt output wise. Feedback, we have 0.00 volts, and we have basically no millivolts on there. So now, in order for us to start getting output, we are going to start increasing the voltage limit potentiometer. You can stop right there. Okay. Okay. So now what we have here is our output. You want to turn on the fan, Tony? There's our output, and we get, this is a 10 millivolts per second. We see all the 6 pumps. We can see that the output is positive, and we've already located so that we have 144 volts DC on the positive direction. At this point, the regulator board says it's on, but we are voltage regulating. The rest is just basically that we have power, and we notice that now under normal working conditions, the 3 red LEDs are off. Now it's only showing red. For this specific 144 volts DC output, we have 1.74 volts DC of voltage feedback across that resistor, and we only have 4 millivolts corresponding to, if we have 200 ohms, 25, that it's 4, so 4 times 4, about 16 amps of current. Okay, so let's go ahead and start. And by the way, we have TV3 between positions 2 and 3. We have it set up for manual polarity command. Alright, so we want to go ahead and increase that, give me a little more on the voltage limit command. We had to turn on our fan because that's fine good. Now we can see that now the waveform looks a little different, but we still have the 6 pumps. It's still positive. According to our meter across the line, we have 255 volts DC. The AC input is probably the same, and nothing has changed. Now I'm going to ask Tony, on a 3-phase system, you're going to get a maximum of 1.3 times the input. If it's 234, 1.3, it's roughly 310 volts. So I'm going to ask Tony to increase that voltage until we get that maximum output, and we can take a look at that. And that's 305 in this particular case, and we can see that get the maximum output. Alright, and one of the things I'm going to show here is that's our output. We have, under these conditions, 3.68, which the maximum it's supposed to be, it can be between 2 and 4. Here we have 3.68 volts, and because of the size of the load, we only have a maximum of 8.5 millivolts, which will correspond to about 33 amps. 33 amps according to what the current clock says. And Tony, can you check that we have here the right setting for the...
Yeah, you got the right delay angle, right? And then you got...
Because we're already at a minimum, so it should be...
Yeah, there's the offset.
Okay.
So
all right.
52 minus 42.
Okay, so about 12 degrees?
Yeah,
all right.
About 10 or 12.
Okay, so now what we're going to do is I'm going to ask Tony to come back to about 250. All right, good. And that's that. And without having to turn this off, I'm going to ask Tony to go between positive and negative. Right now we're positive, it's going to go to negative by changing the connection between 6 and 3. And here it is. Alright, so let's go ahead and take a look at our output. There it is. You notice that we started at 0 and we started slowly going up. Now the DC output is 257. Now it's showing negative. And let's do it again, Tony, but in 1 second. Now we're going to look at the transition LED. Right. So we notice that we inhibited in transition for a minute. The regulator is soft starting, and then eventually that will clear, and now we have again our output. It's 52 on the opposite end. After some time, this LED will go away and we'll only stay again with our voltage regulation. Now let's just go back one more time, Tony. Can you come to about 100 volts? 100 volts on the command. And that's just randomly. You can set it to any output voltage that you want. That's good. And then let's go ahead and take a look at that output. Go ahead, Tony. And there it is. It started and came back on again. And that there's a little imbalance because we're trying to keep the same current, and that's about 110 volts on the opposite. So again, our regulator is slowly soft starting, and that's after a while we're gonna get that. And just one more time, Tony, so that we catch that LED. Okay, ready? Here we go. All right, and this basically it's the end of this second video. The second part of this second video will be doing the same thing now with current regulation.